no one cares about whether a finite series will converge or not, because a finite series is going to converge unless you have infinity pop up somewhere in the middle, but in which case it's not going to. So suppose I have a series I equals n equals 1 to infinity, k sub n, and as n gets bigger and bigger and bigger, this converges to a finite number, let's say L. So as you have an infinite value, it is converging to a finite number. If you want to write it in a different way, you can write it as I equals 1 to n, a sub I, limit n approaches infinity, they are one and the same, converges to a finite number. If it's converging to a finite number, then we have a convergent series. Good? It's converging to a number. So if you know the series is convergent, that must mean that its general term must converge to a finite value. Do we agree? Specifically, what should that value be? If this is converging, as n goes up and keeps on going toward infinity, what should happen to that sequence? For this to converge to some finite number, and then n approaches infinity, what should happen to that sequence so that this series is convergent? Smaller. It should get smaller and smaller. In other words, it has to become 0. So beyond a certain point, if an gets smaller and smaller and smaller, and if it approaches 0, then this sum is guaranteed to converge. Agreed? But if that doesn't happen, then it's not going to converge. Are we clear? So if you know a series is convergent, then somewhere for some value of n, and beyond that value of n, the general term is 0. Good? Now, I'll show 2 cases, 2 different series. Good. So the general term in the first series is 1 over n, agreed? Yes? There it is 1 over n squared. Yes? Okay. Now the sequence we'll call it Bn. Does an approach 0 as n approaches infinity? Yes. Does Bn approach zero as n approaches infinity? Yes or no? Yes. Let's start backwards. Does that series converge? Yes. This is a convergent series. Beyond a certain point, things just become zero. Convergent series. What about that one? Right? Convergent series, that's what one would think. But unfortunately, this is not a convergent series. This is the only case where things don't work out. That's a special series called a harmonic series. And even though intuition tells us, well, it has to converge, it is not going to converge. It is a divergent series, yes.
Is this the 1/12 thing?
I was about to get there. If you look in YouTube, you know, there is a funny proof where, you know, you would write the sum and equate it to -1/12, where you start with 1, you're adding fractions little by little. Somehow, if you use the properties and rules that we know of, the answer would end up being -1/12, which absolutely does not make any sense, correct? Yes? You're just adding positive numbers, ends up being -1/12. Well, that's kind of doing math the wrong way. It has been shown that that is not the case. It's not -1/12. It is a divergent series. But it is a fun video to watch. You can see how they come to that conclusion. Do we see the difference between convergent and divergent series? Yes? Why not?
How are they different?
This one is convergent because the sequence approaches zero. One might try to use the same logic here. This is a special case called a harmonic series. The only case where that will not be satisfied. There is a proof for it. Google, yes.
So for the first one, if n equals 100, and the second one, if n equals 10, it's not.
It converges faster, right?
So because it's exponential.
Yes. So this would approach zero rapidly. So very good point. If n is 100, you would get 0.01 here. But n just has to be 10, and you would get 1/100. Agreed? This is going to converge really fast compared to that. But the proof is more involved. I'm not going to get into that. But this is a case where most people would think that it is a convergent series using that logic, but it's not convergent. Divergent. Good? So if you know that a sequence diverges, then do you think the series diverges also? Would diverge also?
So
If a sequence is divergent, would it make the series divergent? If a sequence is divergent, it means it just blows up as you go, as n approaches infinity. So if a sequence is divergent, do you believe that the series is divergent? Erase. Suppose sequence is divergent. In other words, as n approaches infinity, an doesn't approach a finite value, doesn't become zero, doesn't get smaller and smaller. it blows up. As an example, consider n. Simplest thing. My question is, the series is it divergent or is it convergent? So general term, n equals, a general term is n, so if you generate this, you have 1, 2, 3, 4, 5, dot, dot, dot. That is my sequence of natural numbers. Does that converge to a single value? Or does it just keep on going? Sequence of natural numbers. Does it converge or does it keep on going? Raphael? It keeps on going, do we agree? 5, then it eventually 100,000, 10,000, it can keep on going. Okay, so that sequence is not convergent. Agreed? Well, I want to sum its terms. Let's say I sum the very first 10 of them. I have a formula for it, yes? N times n plus 1 divided by 2. Plug in the formula, you get a number. Then you add 100 of them, 1 through 100. Is the sum going to get bigger or smaller? Bigger. Think of it this way. Today, someone's depositing $1 in my bank account. Tomorrow, $2. Day after tomorrow, $3, $4. In 10 days, I have some money, right? In 100 days, it's getting bigger, correct? In 1,000 days, a lot bigger, correct? 10,000 days, I can leave this planet finally. Does that make sense? Yes, it's getting bigger and bigger. So if this doesn't converge, then that is not going to converge. Does that make sense? Bryce, you're making a face.
So if a sequence diverges, then its series diverges.
Yes. So do we agree that that does not converge? This is a divergent sequence. Yes. I'm going to sum the first 5 terms. Let's use our usual formula. Sum of n natural numbers, 5 times 5 plus 1, divided by 2. Yes, I get 15. Give me a number bigger than 10 and less than 20.
15.
15, okay. 15 times 15 plus 1 divided by 2, which is 15 times 8. 120. Good. Bigger than 20, less than 40.
26.
How much?
26.
26. 26. 26 plus 1 is 27, divided by 2. 13 is 207, say 81, that is 351. Good. Number bigger than 50 and less than 100. 93. 93 times 93 plus 1 divided by 2. 93 times 94 divided by 2. 47. No. Yes. this up. What do we get?
4371.
43871?
4371.
4371.
It's okay. Let it go. What is happening to the sum? The sum is getting bigger, right? 15 became 120, then 351, 4,371. If I pick, say, 256, the next partial sum, S256, is going to be a big number. Do you agree? So that series is not going to converge. Does that make sense? Right? So if you know the sequence is going to blow up, then the series is going to blow up. Erase. I will end with an example, and we can pick that from here next time. One of the commonly used sequences, the convergence sequence, is a geometric sequence. That is an arithmetic sequence. That does not converge. Do we agree? Some of them actually. A geometric sequence is this. When I wrote that arithmetic sequence, I said there has to be a common, as I move from one term to another, they must have a common difference. In a geometric sequence, as you move from one term to another, there is something called a common ratio. In other words, if I divide AR by A, what would I get? R. Or if you divide A by AR, you would get 1 over R. Doesn't matter which way you do it. Likewise, AR squared divided by AR is R. AR cubed divided by AR squared. AR raised 4 divided by AR cubed. R. You get the picture? Yes? So, common ratio. Well, just because you have a common ratio doesn't mean it is going to converge. I'm going to write 2 sequences. Both of them have a common ratio. One of them is not going to converge. You can tell me which one. Both of them are geometric sequences. One is going to converge, one will not.
Bottom converges.
Raphael says the bottom one will converge. Top one, does it converge?
No.
No. The top one is not going to converge. What is the general term of that sequence? Let's say we start n equals 1. We start at n equals 1. No, let's start at 0, because that is from n equals 0. If I start at n equals 0, what would the general term be? So when you put 0, you must get 4. Okay, Caleb says 2x n. Do we agree? When n is 0, 2 raise 0, 1. When n is 1, 2 raise 1, 2. when n is 2 raised to this 4, so on. This one is also starting at 0, 1, 2, 3. When n is 0, you have r raised to the power of 0, which is 1. So this is r raised 0, r raised 1, r raised 2, and so on. What about the general term here? 1 over 2 raised n. Both of them are geometric, but one of them would converge, the other is not going to. Why? Going back to what we did earlier, that sequence is a divergent sequence. It does not get smaller, it doesn't approach 0, but this one approaches 0. Do you agree? Try it at home, pick n equals 32,999. Do 1 over 2 raised 32,999. Calculator might not work, depending on the position, but it would be an extremely small number. That is a convergent sequence, so the resulting series will also be convergent. Does that make sense? Okay.